So this is the practice questions to help you prepare for test 3. I selected the problems very carefully so they can reflect on the actual test. Okay. Use technology to help you test a claim about the population mean at the given level of significance alpha using the given sample statistics. Assume that the population is normally distributed. Okay, claim mu is greater than what? 1250, alpha is 0.08, sigma is 205.02, x bar is 1281.96, and n is 200. What kind of test do we use here, guys? He gives you sigma. What is it gonna be?
Z.
Z-test. Exactly. It is gonna be a Z-test in here. Okay. To choose the claim greater than. So greater than, so that would be the correct answer right here. To calculate the test statistic, guys, we have to go. So I'm gonna switch between the screen and my other screen here. So let me put this into the calculator. So it's gonna be a Z-test. Okay, so I'm gonna go to Z-test. For mu0, we're testing against 1250. I will show you the screen in a second. For sigma, because he gives you sigma, you have to use a Z-test. That's why I selected this question to show you when to use a Z-test. X bar is 1281.96. N is 200. And we're testing that mu is greater than. And if I stop share here and share another screen with you. So number 2, a nutrition claims that the mean tuna consumption by a person is 3.6 pounds per year. A sample of 60 people shows that the mean tuna consumption by a person is 3.3 pounds per year. Assume that the population standard deviation is 1.08. Can you reject the claim? Okay, what kind of test are we using here, guys? He gives you the population standard deviation.
Z-test.
Z-test again. Okay. They claim that the mean tuna consumption by a person is 3.6. So equal or not equal? So it's going to be C. And let's bring the calculator back. Clear. Stat. And you go to tests. Z-test. And now, guys, you input the data that we are given in here. So.
You selected T-test.
Oops, sorry. You're right. It's a Z-test. So mu0 is 3.3. And sigma, let me just get it back. Sigma was 1.08 and n is 60. X bar was 3.3. N is 60. And we have equal or not equal, guys. That's it. not equal. And remember, the claim is in the null hypothesis. That's why he asked us if we can reject the claim. And hit calculate. Okay, so Z is 0. P-value. Oh, I should have put 3.6 there. I made a mistake. That's my mistake. It should be 3.6 here. Otherwise, Z should not be 0. Now it's working, yeah. So Z is negative 2.15. P-value is 0.031. And this is all I need, the p-value to make the decision. So what is alpha? Alpha is 0.05, so it's less than alpha. So find the p-value, which is less than alpha. If it is less than alpha, you reject the null hypothesis. And what do you say? Which one do we select here? If we reject HO, we don't say there is not sufficient evidence. There is sufficient evidence to reject the claim. So actually, it's simple here, guys. You know, when you reject HO, you cannot use the word not. So there is sufficient evidence to reject the claim that the mean tuna consumption is equal to 3.6. Use a t-test. Well, here, guys, it's obvious. He's telling you to use a t-test. So you're not going to do anything other than the t-test because he is asking you to use a t-test in here. So we want to test that claim mu is greater than or equal to 7,800. Alpha is 0.05, X bar is 7,500, S is 430, and N is 24. Okay, let's do this together. I'll bring the calculator back. So stat. I'll be surprised if a student uses a z-test here because he's asking you to use a t-test. So 7,800, it's the value that we're working against. X bar is 7,500. S was 430. And N is 24. But before we do that, guys, can you tell me which one is the null and the alternative hypothesis? So the claim mu is greater than or equal 7,800. What would be the alternative?
Less than.
Yep, that's it. And now let's bring back the calculator. So we need less than. Make sure to select it and press enter, guys, and calculate. Here you go. So T is negative 3.417. A p-value is 0.011. You just input them. The p-value is less than alpha, so you reject HO. And if you reject HO and the claim is in HO, you say there is enough evidence to reject the claim. So let's see which one is going to be. Yep, right here. It will be A. Okay, let's go to the next one. The dean of a university estimates that the mean number of classroom hours per week for full-time faculty is 11. As a member of the student council, you went to test the claim. A randomly selected sample of 8 full-time faculty is shown in the table. Can you reject the dean's claim? So the claim, he says that the mean number of office hours per hour is 11. So it's going to be equal or not equal, this one. So what do you do, guys, in order to solve this problem? You will put the data into what?
L1.
L1.
Could you use StatCrunch for this one?
Yes, you could. You want me to do that? So we can do that. Open in StatCrunch. You guys, can you see StatCrunch window?
Yeah.
Okay, and then you go to Stat T. It's a t-test, guys. If it doesn't give you population standard deviation, it's t-test. One sample with data. Okay, this is the variable, and we need to test the mean against 11. not equal to 11. That's it. That's all I need. And compute. Test statistic is negative 1.514, and the p-value is 0.174 if he says around to 4 decimal places. And if we do that, so p-value is 0.174, we fail to reject the null hypothesis, and there is not enough evidence to reject the claim, because the claim is in the null hypothesis. It says is 11, equal 11. This is where the claim is. So there is not enough evidence. P-value failed to reject HO, and right here. Right here, that would be. Okay, we're almost done with chapter 7. A humane society claims that less than 61% of households in a certain country own a pet. In a random sample of 700 households in that country, 413 say that they own a pet. At alpha equals 0 is 0.01. Is there enough evidence to support the society claim? So their claim is less than 61% own a pet. What would be the null and the alternative? It's a proportion test, guys. So less than, where is the less than? It's going to be right here. 0.61. Watch, guys, how you input this one. And greater than 0.61. And you run a proportion Z test. Okay, and let's do that together. So I'm going to bring the calculator back up. And we have 700 and 413. Remember that. So you go to stat, tests, one prop Z test, 0.61. What was it? 413, 700. And we're testing it's less than 61%. So you do the less than, guys, and calculate. Z is negative 1.08. P-value is 0.1389, and he wants us to test that alpha equals 0.01. So P-value is more than alpha. You fail to reject the null hypothesis. So 0.139, I'm going to write it down just to see how to enter this one. And here, fail to reject the null hypothesis. And there is or there is not, guys. There is not enough evidence to support the society claim. As simple as that. If you just know the steps, you should be able. And don't forget to put the value of Z. Otherwise, you won't get credit for that one. Okay. Now, we're going to chapter 8, section 8.1. I did them section by section in order, guys. So now we have two problems from section 8.1. For the given data, find the difference between the sample mean, find the standardized test, decide whether the p-value is less than alpha, and decide whether you should reject or fail to reject the null hypothesis. Okay, he gives me x1 bar, n1, x2 bar, n2, and he gives me sigma 1 and sigma 2. So what's the name of the test, guys, since he gives me sigma 1 and sigma 2?
Z test?
Yeah, two sample Z test, because he gives me sigma 1 and sigma 2. So I'm writing them down because the calculator covers some of them. And let me bring the calculator back. All right, so you go to stat. X1 bar is 1215. Oh, sorry, I put the wrong test there. Here we go. Sigma 1 is 75. Sigma 2 is 120. X1 bar is 1215. N1, guys, is 45. X2 bar is 1195. N2 is, I copy that down, 85. Okay, the claim is mu1 less than mu2. So you have, it's obvious, it tells you mu1 less than mu2. So you just use this one and hit calculate. Okay, let's answer that question. So I got Z is to be 1.17 and p-value to be 0.878. Okay. Let me just, okay. The difference between two sample means. He wants you guys to give him the difference between the sample means first before you begin. The first one is 1215 and the second one is 1195. So you just subtract them and you get the difference, which is 20. Because 1215 minus 1195 is 20. Now, what's the test statistic that we got of the calculator? It was 1.17. Is the p-value less than alpha? No, it wasn't less than alpha. It was bigger than alpha. The p-value was 0.878. So you don't need to provide the p-value here. Well, if the p-value is more than alpha, guys, you fail to reject the null hypothesis. And if you fail to reject the null hypothesis, there is not enough evidence to support the claim. Okay. Test the claim about the difference between two population means mu1 and mu2 at the level of significance alpha. Assume the samples are random and independent and the population are normally distributed. He gives you sigma 1 and sigma 2, guys, so you have to use two sample Z test. Okay. HA, he gives me HO, mu1 equals mu2, so you guys agree with me that HA should be not equal to. And let's run the test. Stat. Two sample Z test. Okay, sigma 1 is 3.2. Sigma 2 is 1.6. I meant just to do it right online, guys, because I know some students sometimes have trouble even knowing how to input the values, you know, into the answers. So you have to be careful with that. 28. X2 bar is 20. And N2 is 29. And as you can see, we're testing that mu1, the alternative mu1 different from mu2. Make sure to select it and hit calculate. So Z is negative 2.97. He says 2 decimal places. And the p-value is 0.003. So negative 2.97. Okay, what's the proper decision? Alpha is 0.01. Well, this is less than alpha, guys. So reject HO. And the claim is in HO, so there is enough evidence to reject the claim. When the claim is in HO, you have to use the word reject. So let me look for that language. Yeah, right here, A. All right, next one. Researcher conducted a study to determine whether magnets are effective in treating back pain. The results are shown in the table for the treatment with magnets group and the sham or placebo group. The results are a measure of reduction in back pain. Assume that the two samples are independent, simple random sample selected from population that are normally distributed.
I have a question.
Yes.
For the last part of the last question, wouldn't it be there is enough evidence since you're rejecting it?
Yes.
Oh, because you put there is not, which is.
Oh, yeah, you're right. There is enough evidence to reject the claim. And that's what I said. I said there is enough evidence to reject the claim, but I didn't pay attention to the not. You're absolutely correct. Thank you.
Mhm.
All right. Do not assume that the population standard deviation are equal. That means it's a pooled, yes or no. So now, guys, you know it's a two-sample t-test. Let me give you the hint why it is a two-sample t-test. He didn't put sigma here. He put S, guys. So this is a two-sample t-test. So let me bring the calculator up. Well, first of all, use 0.05 level of significance to test the claim that those treated with magnets have a greater mean reduction in pain than those given a sham treatment. So greater mean, it's gonna be right here. Okay, now guys, you wonder why this is not less than or equal to, because I got this from a different book, I believe. So it's okay, just select, you know, the proper alternative sign and this is gonna work. As you can see, there is a 1 instead of A. Some other books use 1 instead of A. So this is the only choice that you have actually, because you wanna select that the treatment is bigger than the placebo. This is the only one that has it right here. I will make sure for the test to customize this and make sure that it will show less than or equal to. Okay, let's do the calculator. Stat, two-sample t-test. Okay, X1 bar, treatment, 0.48. S1, 0.89. Big variation. N1, we have 20 subjects. X2 bar is 0.43. S2, 1.33. And N2 is 20 as well. And guys, we're testing that mu1 is bigger than, the alternative is mu1 bigger than mu2. Okay, he says assume standard deviations are equal. So what do I use, yes or no?
Yes.
Yes. Okay. So the test statistic T is 0.14 and the p-value is 0.445. So 0.14. Okay, well, this is bigger than alpha, fail to reject HO. There is not enough evidence to support the claim. That those treated with magnets have a greater mean reduction in pain than those given a sham treatment. Okay, there's another one. A researcher claims that the stomachs of blue crabs from location A contain more fish than the stomachs of blue crabs from location B. Okay, which one would be the claim? The blue crabs from location A is 1 and the blue crabs from location B is 2. We want to check if mu1 is bigger than mu2. So which one of those four guys would work here? If mu1 is bigger than mu2, that means I explained that to you before, that mu1 minus mu2 is bigger than 0. So which one has the greater sign in the alternative? Just look for the one that has the greater sign in the alternative. Do you guys agree it's what? D. Because that means mu1 is bigger than mu2. Okay, let's run the calculator test on this. Okay. So it's a 2, he says assume that the population variances are equal again. So we're gonna go to stat, tests, two-sample t-test. You might have the same exact problem, guys, on the test, but with different numbers. Okay, let me see what we have here from the first one. Stomach contents of sample. Okay, so N1 is 17. The mean is 193. and the standard deviation is 36. And the second one for location B is 10. The mean is 189, and the standard deviation is 45, and alpha is 10%. All right. Stat. X1 bar, guys, is 193. S1 is 36. And N1 is 17, he says. X2 bar is 189. S2 is 45. And N2 is 10. And we want to test that mu1 is bigger than mu2. If mu1 is bigger than mu2, that means mu1 minus mu2 is bigger than 0. And pooled, yes, because it says population variances are equal. If he says not equal, you select no. If he says equal, you select yes. That's a hint for you to know it's a 2-sample t-test here. Okay, and then select yes, and then calculate. Okay, guys, so t is 0.254, and p-value is 0.401. Okay, what's the conclusion here? Fail to reject HO or reject HO?
Fail to reject.
Yep. And then if fail to reject, there is not enough evidence. Oh, he made it easy for us to support the claim. When the claim is in HA, you use the word support again. And then you get full mark on this one. All right. This is section 3, guys, when the samples are dependent. All right. So it's going to be some work here. One journal reported on a study of homophones selling in patients with a certain disease. 20 patients were asked to spell 24 homophone pairs given in random order. Then the number of homophone confusions was recorded for each patient. 1 year later, the same test was given to the same patients. The researcher posed the question: do patients show a significant increase in mean homophone confusion error over time? Perform an analysis of the data to answer the researcher question. Okay, since it is the same patient before and after an action, guys, you have to do the difference between the two. So what I'm gonna do with you before I do anything else, we're just gonna try to enter the data into the calculator and doing the differences. And let me see if I can move this a little bit. All right, so we're gonna go to stat, edit. I'm gonna clear L1 and just let me stop the recording here so I don't waste time.